thyristors. Thyristor is a control device, unlike diode, where the instant of conduction can be controlled after applying the forward voltage so that the output voltage, current and output power can be controlled. Thyristor is the name given to the family of devices which have a common structure PN and have similar characteristics. Thyristor has characteristics similar to the thyratron tube, and construction point of view it is similar to the transistor. So thyristor is the acronym which is derived by a combination of the capital letters of thyratron and transistor. One oldest member of the thyristor family is called silicon controlled rectifier, SCR. SCR is a 4-layer, 3-terminal, 3-junction PN device. These solid-state devices are compact, possess high reliability and have low loss, and almost universally employed for all high-power applications. So it is the schematic and circuit symbol of thyristor. So it has anode, cathode, gate, 3 terminals, 4 layers PN and junction J1, J2, J3, 3 junctions. Static VI characteristics of SCR. The elementary circuit for obtaining VI characteristics. So first we discuss modes of operation of thyristor. So this is the thyristor in normal mode, anode, cathode, gate. Junctions are in normal conditions. So in the second case, if you made anode positive with respect to cathode, J1, J3 becomes forward bias, whereas J2 becomes reverse bias. Why? Because you see here PN becomes forward bias, PN becomes forward bias, J1, J3, whereas J2 is NP. So junction J2 will become reverse bias. So it is known as forward blocking mode. Only small leakage current will flows from anode to cathode in forward blocking mode. Now if you apply gate pulse, that means if you made gate positive with respect to cathode, so junction J2 also becomes forward bias. So thyristor gets into the forward conduction mode. So now reverse blocking mode. In this case, cathode is made positive with respect to anode. So J3, J1 becomes reverse bias. Only junction J2 becomes forward bias. So in this case, reverse current, reverse anode current. That means anode current is negative from cathode to anode. Small leakage current will flows in the reverse blocking mode. So forward blocking mode means open switch, forward conduction means closed switch, reverse blocking mode means again open switch. So this is thyristor VI characteristics. It clearly shows that thyristor provides only first quadrant operation. So anode is made positive with respect to cathode. Small leakage current will flows, IA. You see here O, from O to M. As the anode voltage increases, leakage current, forward leakage current also increases. Once the anode voltage reaches forward breakover voltage VBO, so at this point VA decreases gradually, right? Suddenly VA decreases, IA increases gradually. Why? Because IA is increasing above the latching current, so that thyristor becomes into forward conduction mode. Once the anode current rises above the latching current, thyristor gets into the forward conduction mode. So from O to M, it is forward blocking mode, we can say. So as long as anode voltage is less than forward breakover voltage, thyristor is in forward blocking mode. Only small forward leakage current is flowing. Once the anode current reaches forward breakover voltage, so anode current rises above the latching current, so thyristor gets into the forward conduction mode. So NK shows the forward conduction mode. So now anode current is equal to the load current. It is based on the load resistance, load impedance and supply voltage, right? Now latching current, it is minimum anode current above which thyristor remains on state, and holding current, it is also minimum anode current below which thyristor gets turn off. This is about first quadrant operation. If you apply reverse voltage, that means cathode is made positive with respect to anode, so small leakage current flowing, so it is in reverse blocking mode, so reverse leakage current is very small. Once the reverse voltage reaches reverse breakdown voltage, current suddenly increases, thyristor gets damage. Okay, so don't operate in the reverse direction, don't apply reverse breakdown voltage for the thyristor will get damage. So reverse blocking state, anode is made anode is made negative with respect to cathode. J1, J3 are reverse biased, J2 forward bias, reverse blocking mode. SCR acts as open switch, small leakage current will flows from cathode to anode. This is reverse blocking mode. The amount of reverse voltage required to get the conduction in reverse direction is known as reverse breakover voltage. Don't try this one, reverse breakover voltage. Forward blocking state, anode is made positive with respect to cathode. Junction J1, J3 are forward biased and J2 is in reverse biased. SCR acts as open switch, small leakage current flows from anode to cathode. Forward conduction state, anode is made positive with respect to cathode. J1, J2, J3 all junctions are in forward bias, so that SCR acts as closed switch, load current flows from anode to cathode. The amount of forward voltage required to get conduction in forward direction is known as forward breakover voltage. If you apply forward breakover voltage for the thyristor without any gate signal, it will get turn on. Turn on of thyristor means forward blocking state to forward conduction state. Turn off of thyristor means forward conduction state to forward blocking state. Now again we can define latching current also. It is the minimum value of anode current above which anode current should rise for reliable turn on of the SCR, so that SCR remains in on state even if you remove gate signal. The gate signal should applied along with SCR till anode current rises above the latching current. Now holding current, it is the minimum value of anode current below which the anode current should fall for reliable turn off of SCR. So below holding current, thyristor gets turn off. It is useful to know the instant of application of reverse voltage during turn off process, so that latching current is always greater than holding current. Thank you very much.